I have two more things I'd like to talk about. One is churn management, the usage of intelligence in churn, and two is the usage of intelligence in digital advertising. I think two topics that are highly relevant for many industries, many companies. Churn, who likes to see their customers leave? Nobody. It's a major problem in various industries. Think about telecom, think about any subscription business, any business really. The problem is, of course, we don't like to see our customers leaving, and we want to take some action to avoid that those customers will leave, right? That's the idea of churn management. Okay, great. The problem is, we don't know in advance who's going to leave or not, right? People look the same to us. How are we going to say who's going to leave or not, and how are we going to adapt our actions based on that? Okay. Traveling back in time, 20 years ago, major problem. Now, not a big problem anymore because we can track how customers have behaved, who has churned in the past, who has stayed with us in the past, and we can ask Siri or any other machine to make predictions about who's more likely to churn. Now suppose we've built a data set, we've applied a matching algorithm, and our matching algorithm tells us this customer is highly likely to churn, has an 80% of churning. This customer has a 50% chance of churning, and this customer has a 20% of chance of churning. Okay, that's predictive analytics in the context of churn management. All right? Then the question is, what is next? So we've answered the question, does this look like that? But now the question is, which action are we going to take to minimize churn? And that's a very important question. That's not a does this look like that question. That's a question of, if we do this, what is going to be the effect on a customer's likelihood to churn? And ideally, we want to direct our actions to those customers where we can have a larger impact. That distinction is very important. Does that make sense, that distinction? It is a very important distinction, and it is one that is not recognized in current business practice. Just to give you a few examples, I want to show you a few quotes, all taken from documents from major consulting companies, so major players in the area of churn management. And what you'll see is that they all do the same thing. By modeling customer churn, businesses could identify customers that are likely to stop engaging with the brand. So how do you know a customer is about to leave, and how do you take action before it's too late? In this post, we'll discuss how to measure indicators of churn, how to use that data to predict the likelihood of customer churn, and how to prevent at-risk customers from churning before it's too late. Notice how they're conflating here matching with explaining. Matching is this like that? Is this customer like a customer that is going to churn? Explaining is, what can we do to avoid that this customer will churn? How do you know a customer is about to leave is this like that question. How do you take action before it's too late is a explanation question. Machines can do this very well based on analyzing historical data, just like I showed you with the little Excel file. This here is much more difficult to do. Churn is the process of customer turnover or transition to a less profitable product. With customer churn rates as high as 30% per year in some global markets, identifying and retaining at-risk customers remains a top priority for communications executives. Again, here, this is from a major consulting company that was working with a telecom company and was describing what they've done for them in terms of churn management. The company needed deeper insights into customer priorities and behaviors to reduce attrition and improve competitiveness as new companies entered the market. The client wanted to identify customers with high risk of defection and implement ways to retain them. All right, I want to really make clear that what they're doing, what everybody is doing is this. This is the person that we should be trying to influence. But that could be a big mistake. That could be a big mistake. Okay, let's make clear this. Is this like adapt versus explanation, or matching versus explanation in a different context? Weather forecasting and what to do about rain. Okay, if I can use a matching algorithm to predict whether it will rain or not. Is this like a that? Is this like a day that it will rain? What can I do in response to that prediction? I could bring an umbrella so that I don't get wet. The umbrella that I bring has no influence on the likelihood that it will rain. Okay? I can take precautionary actions to make sure that I don't get wet, right? So is this like a that question is not useless. There's many useful things about it, but it's a different question from an explanation question. Okay, let's think about this in a context. It's raining and I don't want it to rain. Let's do a sun dance. Okay, I start dancing in the hope that the rain will go away. Okay, so that's an explanation problem. I'm trying to have an influence on the likelihood that it will rain. Okay, it's the same thing with churn management. Is this a customer that is likely to churn? Is an interesting question because it allows you to make predictions about how valuable that customer might be and whether you should try to get more customers like that or avoid customers like that and so on. There's stuff you can do with the answer to this question. But it is a different question from this question, which is, I want to make you stay. I know that you're likely to leave, but I want to do something that will make you stay. Major distinction and an important one. So how do you figure out who to call or who to approach? We need more than just tracking past behavior of consumers. We need to proactively create a data set that allows us to figure out who will respond more positively to us and who will respond negatively to our intervention. So we do an experiment or an A/B test or a randomized controlled trials. So what is an experiment? What is a randomized controlled trial? We're going to say, we don't know who we need to call, who to direct our intervention to, high churners or low churners. We don't know, so we're going to randomly divide customers into two conditions. One group of customers, we're going to make an intervention, and the other group of customers, we're not going to do anything. Then we're going to record what they do, and we're going to see if there's any differences between those groups. That is incredibly useful information to have, because once you've done an experiment like this, you know whether your intervention was successful or not. Okay, let me show you the data of one experiment. This is a membership organization in the US that had been doing, just like other companies have been doing, targeting customers that are highly likely to churn for years. And then at some point they were persuaded that, maybe we're making a mistake. We actually don't know why we're doing this. Let's do an experiment. So what they did was divide their customers into two groups. These customers, we're not going to reach out to them. These customers, treatment here, we are going to reach out to them. We're going to do an intervention to make it more likely that they will stay. We're going to, what you're seeing here, is a comparison of control group and treatment. And the customers are ranked here into deciles. These are the 10% customers for which our algorithm predicted that they're most likely to churn, right? These are the red guys. And these are the 10% of customers that are least likely to churn. Notice the effect of the intervention on the customers. It is actually increasing churn likelihood for customers that are most likely to churn, and it is decreasing the churn likelihood for customers that are less likely to churn. This is an incredibly important insight, because if the company had just kept on doing what it did or followed standard practice in the industry, they'd been doing this. These are 10% customers that we think are highly likely to churn. Let's do an intervention. Let's go after them and persuade them to stay. But their intervention is actually backfiring. It's costly, and they're increasing the likelihood that their customers leave. This is where human intelligence comes in. Artificial intelligence tells you, is this like that? Human intelligence separates the two and tells you, what is the question that we want to answer here? The is this like that question, or is it an influence question? Do we want to change the likelihood that our customer will leave? Okay, another example. Also a real example. This is an South American telecom company. Okay, they had found that 64,000 of their customers were in a payment plan that was suboptimal for them. So they had, I think, 3 payment plans, and they knew that these customers were in a plan that was good for the firm, but actually bad for the customers. They were paying too much. They had another plan that was better for them. And the question is, you know, we want to reach out to those customers and tell them that there's a better plan for them. That's a good thing to do, right? In order to make it more likely that these customers will actually be loyal customers in the future. Should they? That's an explanation question. We don't know, so let's run an experiment. So what the company decided to do is to say we're going to split customers in 2 groups. Some we're going to call, others we're not going to call. So here they decided to call 54,000 customers and not call 10,000 customers. These customers, they were called and said, hey, you're not in the right plan. We have a better plan for you. Do you want to switch? And these customers is the control group. They did not call them. They're also in a bad plan for them, but the company did not call them. And then they're tracking churn, whether these customers churned in the next months. Now, notice that these sample sizes here, they're unbalanced. More customers here than here. That's perfectly fine in an experiment. You don't have to have balanced sample sizes. It does tell you something about the prior beliefs of the company. They said we're going to call the majority of customers and not call a minority of customers, meaning that their managers believed that calling is the best thing to do, right? And they were okay with having a control group, but let's make it as small as possible because we believe that's a bad thing. Like, we should be calling them in order to minimize churn. Okay, so that's one thing I want to point out. Then let's think about these churn numbers here, because sometimes experiments are interpreted in a flawed way. So they're finding that 5.9% of customers accept the new plan. Sorry, that 5.9% of customers that accept the new plan churn in the next 3 months. 6.5% of customers that they didn't call churned in the next 3 months. And so the comparison, an oftentimes made comparison, is to say 5.9 is lower than 6.5, so this worked. The problem is, of course, there's many customers that don't accept your promotion and you want to know what's going on with them. So here's all the data that you would have to look at. There are 64,000 customers. Some people we do not call. Other people we do call. Some accept the promotion, but a large majority rejected the promotion. Look what this does. Calling your customers, this telecom company, calling their customers and saying, hey, you're not in the right plan, we have a better plan for you, dramatically increased churn. That's an explanation question. It requires experimentation. We need to do more experiments to understand how the world works. Now, the psychological reason here for why these customers churned is because we woke them up. They were sleeping. They were paying their bills. And we say, hey, wake up. There's better plans for you. There's other competitors there, and so on. And so they leave. So we need to be careful about these issues.